We are now in topic 3, the response characteristics for the first order system. We will learn to write the form of the response by inspection. No? And each pole of the system transfer function that is on the real axis generates an exponential response that is a component of the natural response. And the input pole generates the forced response. I hope you could still imagine this as we have discussed this in topic 2. Okay? So our forced response or the input response, yung K1, no, doon sa ating time response equation. Okay? At yung mga K2, K3, K4, and so on, wherein they have an exponential function there, comprises our natural responses. So for our first order system, for example, we are given this system, okay? The RS is equals to, or rather, our transfer function GS is A over S plus A. And the S-plane plot will be like this. Notice that we don't have a zero for this type of the transfer function. As we all know, the output transform equation is the CS, which is RSGS. Once more, if we use a step function for the input 1 over S, then our CS will be like this. Getting the inverse Laplace of this, no? Inverse Laplace of 1 over S, we get 1. And inverse Laplace of 1 over S plus A is negative e raised to negative at. Okay? So the input pole, 1 over S at the origin, generated the force response, the C of T. And the system pole at negative A, and generated natural response, which is this one, no? As we could see already here. I would like to emphasize that in our example 1 above, it's also an example of a first order system. No? So S plus 2 over S times S plus 5. Okay. In this example, we have a 0. But in this example, we don't have a 0 value. Okay. Only poles. Okay. Now, what is the time constant, no, of a first order system? Okay, so this curve is an example of a first order response curve. And from here, the time constant is the 1 over A of the response. So this one, no? From 0 to time is equals to 1 over A. That is what we call time constant Tc. And that time constant is the time it takes for the step response to rise to 63% of its final value. So in this example, if the final value is 1, 60% of 1 is 0.63. Okay, so this is our curve. This is the graph of our function. And at 0.63, that is the location of the time constant. Whatever is the time na narating dito, that is the time constant, and that is equal to 1 over A. If we're going to substitute the value of the time, which is 1 equals to A, to this exponential equation e raised to negative at, so A times 1 over A will be equal to e raised to negative 1, and that is a constant that will give us 0.37. And since our function Ct, take note, the time response equation Ct represents this graph, right? So the value of the CT at the time constant t is equals to 1 over 80, and ano yung value ng graph? Ano yung value ng amplitude ng graph at this point? Okay? So that is the 1 minus 0.37, which is equals to 0.63 ang value, as I mentioned earlier here. Okay? That is for the value of 1, kung 1 yung ating final value. Okay? O syempre, accordingly, pag nagbago ang final value, still 63% of it. Now, the rise time is defined as the time for the waveform to go from 0.1 to 0.9 of its final value. So, the rise time is found by solving from the CT, the C of t, which is equal to C of force plus C of natural, which is equals to 1 minus e to the negative 80 for the same example above. And with the same way of solving earlier, we substitute the time to be at 0.1. So what will be the CT? And if we're going to solve the time to be at 0.9, what will be the value of the CT? Okay? So for the difference in time at CT equals to 0.9 and CT equals to 0.1, then it would be for CT is at 0.9, that will be 2.31 over A minus 0.11 over A, and that will be 2.2 over A. Okay? Now, paano nakuha yung 2.31 over A at 0.11 over A? I want you to do that on your own based from the same computation we did in the previous slide. That is for you to practice. And then the settling time, TS. Settling time is defined as the time for the response to reach and stay within 2% less of its final value. Okay, so the CT, same equation, because we are discussing here the same transfer function, the A over S plus A. Okay, so our CT in this case will be 0.98. And solving for the time t for that given CT, we could find the settling time to be Ts equals to 4 over A. So once more, how did we arrive to 4 over A? No? From this equation pa din, we substitute the 0.98 here and solve for T. Okay? Okay. For our example, for the first order response characteristics, let's provide the value of A for the same function that we've been discussing. And we're going to solve the time response CT equation. So the time constant TC and the rise time TR and the settling time TS. Okay, so note that the input response is still RS to be a step response, 1 over S. Okay, so apat po no ang ating hinahanap dito, no? The CT, the TC, the TR, and the TS. So here they are. So time response, CT given this equation, so we simply substitute the value of A. So this is now our time response equation. For our time constant, it's 1 over A, so we simply substitute. That will give us a value of 0.43. For the rise time, the TR, this is the formula. We simply substitute A in the denominator and solve. That will give us 0.314. And for the settling time formula, T over S, that's 4 over 7, that will give us 0.571. Now, if we're going to put this equation, this transfer function, in MATLAB, okay, the 7 over S plus 7, it will give us the following characteristics. So let's compare. For the rise time, okay, so ayan po, no? Ayan. Okay, so we're almost accurate. For the settling time, 0.571, okay, 0.559, so there's a slight difference about it, but that is still acceptable. Okay, so actually there's no time constant here, but that is 0.43, and we could verify that from the graph. So in the graph, we have here the time constant 1 over a to be 0.43. So, andito yun, no? So, from 0, if this is 0.5, this is 1, and this is 1.5. By the way, this is the graph given by MATLAB. Okay? So, if this is 0.5, so, nandito yung 0.143 almost. Okay? And that is at about 0.63 of the final value. Okay? And for our rise time, that is from 0.1%, no? Ito, no? Nag-touch yung ating curve at 0.1, and then nag-touch din siya at this point at 0.9. So that length of time is 0.314. Okay, does it make sense? Yes, no? Because hindi pa siya umabot sa 0.5. Okay, so 0.314. So it gives us a more accurate answer, no? While for the settling time, okay, it's about 0.98, no? So, ayan, it's almost close, okay? So, if we could zoom in further, we would see a difference, no? So, that is 0.571. So, this is 0.5, this is 1, so half of between 0.5 to 1, no, it's 0.7 almost, okay? So, that's how we plotted it. And by the way, the slope, no, the rising of this curve is guided, no, by this initial slope, which is equals to 1 over the time constant, or that is equals to a, no, meaning the slope, no, is equal to a. Okay, so it's 7 over 1, no? So if you will notice, it's from 0 to that point, no, it has a slope of 7, which is the value of the a. Okay, so that's it.